Welcome. If I have 5 oranges and I give 3 away, how many do I have left? Hello, my name is Paul and this is Bare Bones Tech. In mathematics, it's not uncommon to want to be able to reverse an operation. In many cases, operations have a partner, a mirror image, an opposite, or to give them the correct name, an inverse. In the last video, we looked at addition. This time we're going to look at the inverse operation, subtraction. Once again, I'm guessing that most of you already know how to do this, although I'm willing to bet that for many of you, subtraction is instinctively more difficult than addition. Hopefully by the end of these few minutes together, it will be just as straightforward. Okay, so let's begin with the example from the introduction. We can once again use our number line to figure out the answer. As with addition, we begin by locating the first number, 5 on the number line. Again, as before, we then count 3 spaces. However, this time we count in the opposite direction. So 1, 2, 3, and we can see that we land on 2. We have 2 oranges left. We say that the difference between 5 and 3 is 2. Again, we require some shorthand. For addition, we used a cross to indicate the operation. For subtraction, we use a dash or hyphen. We also tend to use the words take away or just take instead of tripping over the multisyllabic subtract. So we say 5 take 3 equals 2. Once again, this method of counting along the number line works, but it faces the same issues as we saw with addition. It's inefficient for large numbers. Now, in order to become proficient at addition, we learn the number bonds. When working with decimal, we use the number bonds up to 10. We're going to need those again as we explore another algorithm. Let's consider 46 take away 12. As with addition, we write the two numbers down one below the other with the units aligned. The standard format is the same as for addition, but with the subtraction sign. Following the same process again, we begin with units, using our number bonds to determine the differences, one digit at a time. So 6 take 2 is 4, so we write 4 here. 4 take 1 is 3, so we write 3 here, and we have our answer, 34. We do, however, have a potential problem. Let's consider 1234 take 247. We write it down in the format. Start at the unit's end. 4 takes 7. The number we are taking away is larger than the one we are taking away from. This is actually the result of something we saw when looking at addition. If you recall, sometimes a single-digit sum gave us a 2-digit answer, which caused us to have to carry it over to the next column to the left. We have the same situation but in reverse, and we need to handle it. There are various ways of recording the process. When I was a child, my teacher taught it as borrow and pay back. When you borrow 10 from the next column and place a 1 here, then pay it back down here. We now have 14 take 7, which is 7. When we then process the next column, we have 3 take 4, but we also need to pay back the one that we borrowed. This way of working is nice because it allows us to consider a single-digit column at a time and neatly mirrors the addition process. It's a carry in reverse. Unfortunately for many people, it becomes about the method and we're trying to understand the underlying process. Another way to look at it, known as decomposition, is when we reach the 4 take 7 situation, we break down or decompose the number to the left, in this case the 3. So we decrement it and again write the 4 as 14. Again, we have a result of 7 and we can move to the next column. Now, even though it isn't currently popular to teach it in schools, I think the borrow method lines up with what we learned for addition better, as well as allowing us to consider one digit at a time, which fits better with our algorithmic approach. So let's continue with that. 3 take 4 and the carry can't be done, so borrow 10 and pay it back. 13 take 4 and the 1 leaves 8. 2 take 2 and the carry can't be done, so borrow the 10 and pay it back. 9. We have run out of digits, so we have our answer, 987. Notice the symmetry in this compared to the addition we did last time involving the same numbers, and you can see the same carry process in both. You can expand this to numbers with a lot more digits, and the algorithm will still work. It will also work if we change the number base. Let's consider binary. It is bare bones tech after all. Let's try 12 in binary, 1100, subtract 5 or 101. Write them down. Start at the left. 1 from 0 can't be done, so borrow, in this case 2, and pay back. So now we have 1 0 take 1, which is 1. Next column. 0 take 0 and the carry can't be done, so borrow and pay back. 1 0 take 0, take 1 is 1. 1 take 1 and the carry can't be done, so again borrow and pay back. 1 1 take 1 is 1. Finally, 1 take 0 and the carry leaves 0. So we have our answer, 0 1 1 1 or 7. 12 take 5 is indeed 7. In the next video, I'll be examining a side effect of subtraction, negative numbers. If you don't want to miss that, you know the drill. Please subscribe and ring the bell. While you're at it, likes are appreciated and comments welcome. Finally, share this video with other like-minded folks who you think would enjoy it. Once again, my name's Paul and this has been Bare Bones Tech. Until next time, thank you for watching.